Everybody. Welcome to the Mindplex Pubcast. Today we are talking about AGI for B2B, and we've got TrueAGI, and we have Grace Robot. Grace, say hello. Our lovely
Hi,
co-host.
everybody.
And we will have Ben Goertzel soon. He's coming soon. And we have Matt Ikle, the Chief Science Officer for TrueAGI. Say hi, Matt.
Hi, everyone.
And then we have Alexey Potapov, who is the Chief AGI Officer for TrueAGI. Say hi.
Hi.
and I thought we would start off with Matt. You could give us a little rundown when we talk about AGI for B2B or enterprise AGI, and what TrueAGI does in terms of helping businesses kind of insert AGI into whatever else their specialization already is. And we could start off with a little introduction from you about that.
Sure. So AGI for B2B or for enterprise use is basically it's AGI as a service. It can be customized. It is a general AI service, so it can easily be customized for many different vertical markets for different use cases. And the key is the G in AGI, so artificial general intelligence, which for I'm sure many in the audience know, Ben has been working on for many years, the father of AGI, and the team that he has gathered for TrueAGI includes a number of people who've been with Ben on this incredible journey in the development of AGI. That's where I want to frame it. So
okay, cool. Oh, and I want to mention too that today we have a special feature for everybody when you can ask Grace Robot questions. You can ask us all questions, of course, but I just wanted to make sure everybody knew that today Grace Robot is in the mix, and she'll be able to ask your spontaneous questions, and we'll get spontaneous answers. So that'll be interesting. So Matt, you brought something up before the show that was just really interesting, and we might as well start there. In terms of this idea of emergent phenomenon, emergent behavior, in the sense of behavior that something wasn't originally programmed to execute, in terms of like a hard-coded rule set or things like that. And this is the sort of stuff that people think that LLMs might do. Of course, there's literally no chance, I don't think, of that ever happening. And this is the difference really between things like LLM and the kinds of AGI that we're trying to build. And to me, it was really interesting talking about how you had, what was the word you used? Glimpses of emergent behavior in the original OpenCog, the classic OpenCog. And basically for this new version of OpenCog, Hyperon, you were sort of really capitalizing on what you think was causing that. Could you tell us more about that?
So, and actually, Alexey was involved in some of those earlier.
Whichever one of you want to talk about it.
Experiences. I was talking to Lisa just before the broadcast, Alexey, about the smart traffic analytics system that your team worked on.
Yeah, my mic wasn't working, but actually I heard you.
Oh, okay, right.
Oh, good. So yeah, whichever one of you, if you have firsthand knowledge, if you did the thing, did you do the thing that we're talking about, Alexey?
Partly. So.
Oh, well, then you tell us about it.
Well, first of all, I would like to say that emergent behavior is actually quite vague thing, and it's difficult to say whether LLMs possess any emergent behavior or not. I would say that they do possess some form of emergent behavior, but it can be quite different, and there is a sort of emergence from learning, and of course, even if you just reproduce what you have learned, but with even quite simplistic, I'm not talking about LLMs, but even much simpler learning systems, if they just don't just reproduce things, but combine them in any ways, then it's already a weakest form of emergence in any case. And LLMs.
Wait, you and Ben were talking about last time in the podcast how cutting things up and rearranging them like LLMs do.
So
is not emergent behavior. So clear that up. It's not, right? I mean, that's just cutting things up.
I mean, it's not a binary question. It's not black and white. It's always the question of degree. Of course, quantity can be different from quality, and when we have some quantity, it doesn't matter. Then it's qualitatively different, but still, I would like to say that. Well, it's a vague term. What is emergence? And we cannot just claim, no, they don't have emergent behavior at all.
Okay.
But
so are the hallucinations possibly emergent behavior?
Yeah, you can say something like this. It's maybe not too useful example of emergent behavior, but why not? Because they
counts.
make up stuff, and if they could make up this stuff in a useful way, then why couldn't we call it emergent behavior? But in any case, what I wanted to clarify is that, of course, learning produces some emergent behavior in any case, but it's not only about learning, because reasoning, it's not necessarily purely symbolic reasoning, but we are talking about real reasoning, whatever it means. It also can produce an emergent behavior, because when the system can come up with a novel solution, it doesn't necessarily be a learning process. It can be a reasoning process, and it's really different from what LLMs show. And in this work which you mentioned about traffic analytics, and it actually was not only about traffic analytics. We applied same techniques for analyzing human behavior. When COVID started, there was a need for social distance measurement and other stuff. So in this case, we had both. We had some form of emergent behavior in terms of both learning and reasoning, but of course in not a somewhat ultimate form, but still. And there were different components both to learning and reasoning. And for example, in case of street scene analysis, we performed a sort of anomaly detection, and there were which we called known types of anomalies and unknown types of anomalies. And known types of anomalies were inferred through reasoning, while unknown types of anomalies, it was more about learning. So we had symbolic learning for inferring new rules to recognizing new situations which are not covered by rules. And yeah, it was well. It was.
That's what you're calling an anomaly when something happens that's different than the rules. What's an example of an anomaly?
Yeah, for example, oh, I'm not sure. Some examples might be too weak and others are too strong. For example, I don't know if there is a road which has never experienced a traffic jam, and your system doesn't know about the way how traffic jams look like in this concrete scene, and then construction work has started on this road, and suddenly there are either no cars at all, or cars are moving only in one direction, and you did not did not envision such situations in your knowledge base, in your ontology, in your rules, but your system is seeing that something strange is happening. Then we can call it an anomaly detection. Or if it's not about cars, but for example about people who are walking on street, pedestrians, or well, riding bicycles or whatever. And I'm not sure. For example, there is once again some obstacle, and people start working around this obstacle, and you see that something
like human emergent behavior when they
route
around it.
Or for example, if there is a fight and a lot of people have stopped and are not moving, and the system sees that yeah, it's an anomaly, so it has not yet happened here before. Yeah, I don't consider much more exotic cases like UFO landing. Basically, we're working not on we processed images, but it was like pre-processing, and the system worked on tracklets, not raw images.
Oh yes, let's talk about that. He was talking about doing PLN inferencing on tracklets, and is that the same thing? That was with regard to a talk that was given in 2019, but is that the same kind of thing that's being done in these other scenarios?
I just wanted to mention that we couldn't detect UFO landing as itself, because we didn't try to analyze anomalies on raw images. But when we could see anomalies from tracklets, then yeah, it could be detected, and there were yes different.
So what's a tracklet?
Yeah, okay. Tracklet is a small patch of tracked motion.
Okay.
So you are tracking cars, bicycles, pedestrians, etc., and these tracks can be interrupted by some occlusions and so on. And if you consider small pieces of these tracks, we call them tracklets.
Okay,
and
great.
This is what the lowest grain level of our analysis.
So what was the emergent behavior that the classic OpenCog demonstrated, the glimpse of the emergent behavior?
Well, we, as I said, there were different aspects to it. One of them was grounded predicate learning. So we used a pattern miner, not our team, but Neil Geisweiler. He tried to use a pattern miner over tracklets loaded to atom space. It's a container of OpenCock's knowledge in order to find some predicates. I don't know how it to formulate in more convenient terms. It's predicates, so it's
Predicate's
a logical function over some knowledge over some data.
Okay.
And yeah, I hope it's clear. And it was partly successful because OpenCock and the pattern miner at particular at that time was not too well suited to that fine-grained analysis, because it was quite extensive search for all possible patterns over these small pieces of data and their relations to each other in order to figure out some predicates. But there were some glimpses of this approach in terms of finding some really interesting things. And but basically, this pattern miner was guided by surprisingness of patterns, and some discovered patterns they corresponded to some real stuff which OpenCock in this experiment didn't know a priori, like a car is parking. So it has had no idea what does it mean, but from discovering interesting patterns, it could create a concept of a car which goes to the side of a lane and stops and remains there. But there were more interesting.
So it created a tracklet. Did it create a tracklet?
It created a predicate over tracklets.
Okay. Okay.
But I would say that there were more interesting cases, prior cases to this of using pattern miner, like and Matt can talk more about this, like discovering some genetic patterns for which correlate to longevity. I remember it's quite an old work about using Moses, which is an evolutionary programming learning, and PLN together. Okay, but if we are talking about this more recent work, there was another component to this sort of emergent behavior, which was based on a higher level reasoning components. And in our case, we also not only did pattern mining over this tracklet data, but we also had some higher level or meta rules for inferring lower level rules, like rules which try to infer cause and effect relations. And for example, these rules could do such things like they could infer that people who came together to some place will most likely leave this place together. And this was not a rule which was coded a priori, but this was a rule which was discovered not by pattern mining, but by a causal relation meta rule. Yeah, so these are some examples of symbolic learning and reasoning for emergent behavior in street scene analysis. I hope that this is enough.
Yeah, no, that explains, what you were talking about. And so then you wanted to tell us about the new OpenCog or the new Hyperon. Let's talk about specifically. Oh, wait, actually, let's see. I think let's see. I think Grace had a question about that actually. Grace, didn't you have a question about the meta programming language?
What are the most important components of the meta programming language?
Either of you?
Well,
Alexey's doing a lot. Steve
an answer
Vitali.
to this question. Would you like to answer it?
I'll let you
Which
go
one of you?
for this one.
Well, the question is a little bit unclear because
what does it do? Well, I mean, what does it do? This is a question I get a lot too, because meta is kind of like an important part of Hyperon, right?
Yeah, but
special sauce. So what does it do? How does it work?
If we are talking about most important components, then maybe it's a little bit different. But yes, so basically, OpenCog Hyperon is a rebuild of OpenCog Classic, how we call it now. It was highly influenced in its design by OpenCog Classic, of course, and initially we just wanted to make a clean rebuild with minimum changes to its core functionality, just to make it more convenient and more efficient in certain aspects which we encountered in practice while we were working with OpenCog Classic. One of such aspects is, for example, neural-symbolic integration. We wanted to make it more native. It was a little bit not too natural in OpenCog Classic, and while we managed to do this, there were still some inconveniences in proceeding further. And another inconvenience was just we wanted a more concise language which is more suitable for humans. Although the idea behind ATOMs, it's language over OpenCog Classic Atom Space, was that it's kind of language more for artificial agents rather than humans, and they don't care. I mean, artificial agents, how it is written, they are working with representation of programs in atom space directly. But still, practice shows that it's still humans who are writing programs in this language. But once we started to develop a new design for OpenCog Hyperon, and we started with redesigning ATOMs, and it became a new language which we call MeTTA. We moved quite far in different aspects, like introducing recent advances in type systems, like probabilistic dependent types, and so on. And we tried to account for also novel ideas which we came up with while working with OpenCog Classic on different tasks like more natural support for probabilistic programming, also PLN, probabilistic logic networks, which were mentioned before. They are based on the unified rule engine developed by Neil Geisweiler. And it was not developed in Atomiz itself. It was developed in a reference language. So Atomiz wasn't quite enough for developing reasoning processes. And one thing which we wanted from MeTTA is to support the unified the unified reasoning engine like processes within MeTTA itself. So we don't need to write a reasoning engine in C++ or Python or whatever. We already have it in MeTTA. And basically, it's maybe the answer to your question. There are also some additional things which we are working on and trying to introduce to MeTTA right now, like concrete ways of dealing with parallel processing. We are right now considering Rolang as possible compilation target for MeTTA for parallel processing and so on, while it was not supported in OpenCog Classic. There were different ideas about how this distributed and parallel reasoning over knowledge bases should be done. And one of possibilities is to have a distributed atom space by itself. So OpenCog Classic supported the possibility to have multiple atom spaces which could be distributed, and you could kind of manually address all of them. But it was like too low level in terms of you needed to code this. But in the distributed atom space, this distributed computations should be done under the hood. And also working with, it's not precisely dependently typed systems, because it's kind of broad, but working with this mathematical formalizations of the language, they help to provide a provable way of writing programs. And it's important, for example, for AI DSL. It's not yet implemented in MeTTA, but we hope it will be possible to support such sort of things in MeTTA quite soon. And it's quite important for such projects like SingularityNET and its ecosystemic spin-offs to work with smart contracts, to be able to write different nodes which run different AI services, which can communicate to each other in some provable way, as it's on smart contracts or not. So yeah, I hope it's a little bit.
No, it makes sense. I would love to hear more about distributed atom spaces. So this sounds like this is a really important part. And Ben actually whipped out the paper and was doing metagraphs and knowledge graphs and stuff like that in previous pubcasts. And so I just again like to kind of reinforce, what's a distributed atom space? How does it provide a knowledge representation architecture, basically, for for the systems to, I think, infer upon, but I don't want to say it wrong. One of you explain it right.
Well, I wanted to follow. I'll get there, but I wanted
Okay.
to follow up.
Oh,
on
you want to say
what
something about what we
Alexey,
were talking about before? Oh, I'm sorry. We
and I
can
think it guides
go right
into,
ahead. Yep,
some
absolutely.
recent, literally.
Emergent stuff. Okay, don't let me switch
No,
topics.
I'm not going on the emergence. I was going to,
Oh.
what Alexey was talking about in terms
the
of
meta.
meta.
Meta. Okay.
I could
Let's
bring up
finish
a
up
whole
on
nother
meta.
example of emergence, which would tie together PLN and another component of
Okay,
OpenCog
do
Classic
it.
that we're porting over to Hyperon, called economic attention networks.
Okay.
I might come back to that. I want to, in essence, Meta, in my view, is taking advantage of some really recent advances in mathematical theory. And Alexey hit the word right on the head when he talked about making everything more native. And in that sense, it's more native to computational theory. We're working on computers. And that brings up the whole issue of we have success. We've already had successes with classic OpenCog. And this was kind of the point I was wanted to bring up with the emergence idea. And what we're doing now with Meta and the distributed atom space, and Alexey mentioned Rolang, is essentially accelerating what Classic did by taking advantage of all sorts of optimizations and efficiency enhancements. And that includes the ability to operate on the distributed atom space. By the way, as an update, literally this week, Andre had his first successful tests implementing a very basic distributed atom space over 5 servers. So if you start thinking about that, that's one of the advantages of distribution.
Explain that
It's the ability
a little bit more.
to not just, pardon?
Explain that in a little bit more detail, what you're talking about.
So essentially, if you think about what makes a lot of standard large tech systems work really quickly, is that they're able to harness massive server farms because they built the technical infrastructure to do that. And that includes software infrastructure, taking advantage of hardware. And we're in the process of trying to do the same thing for AGI that, say, Google and OpenAI can do for AI. And in order to take advantage, and that's why we're working on the AGI chip,
right?
Because that
with Simuli.
Alexey talked about the pattern matcher, and in order to the standard,
the OpenCog chip.
The OpenCog chip, right? The pattern matcher needs different processes to optimize different processes versus
hey, we've got a photo bomb. Welcome, Ben. Can you hear us yet? Go ahead.
And so we're essentially what we're trying to do is really scale the classic OpenCog up to much larger scales. We were kind of reaching the limits, and now
you're combining
by
it with
taking advantage of these efficiencies and these optimizations, making things more native, taking advantage of parallelization, taking advantage of algorithmic improvements to focus attention in particular directions. Every single piece of that is adding to this technical infrastructure for AGI versus
just AI.
yeah.
Right. Okay. So Ben, are you there? Can't hear you. You probably just muted though.
Yep, I'm here. I'm here.
All right.
Now. Yep.
All right. Live, crazy,
Hey.
and unmuted. So we are talking about MeTTA, and we're talking about actually what you have gone into detail before on the show with Rachel, talking about the OpenCog pattern matching chip. And we're talking about the way that combining MeTTA with that and the possibilities of all that. That's kind of where you hopped in.
Cool. Yeah. I mean, I think that the chip that I designed together with Rachel certainly is part of the story. It's not the nearest term part of the story. And
I was just letting you know right where we were when you hopped in. Finishing up a discussion of MeTTA.
Cool. Yeah. The question of MeTTA. All right. Yeah. So I think, as Matt was saying, we had what I think was a pretty robust conceptual approach to AGI in OpenCog Classic. We wrote a bunch of books and papers on it. There were many research problems still to be resolved to get from here to AGI, but we felt we had a framework within which we could explore these research issues, right? But we were finding not enough scalability in the OpenCog Classic system, and also not enough usability in a number of respects. Hard to onboard new developers, but also hard to interface OpenCog with external libraries like ones running deep neural networks. So it was a horrifying and painful decision to rebuild OpenCog from scratch, because I knew it would take a long time and just take a lot of work, and we'd all rather be building AGI than building tools on which to build AGI. On the other hand, it's being a fun and interesting process on its own. I mean, we now have like the first sort of early alpha version of the distributed atom space of OpenCog running with a Flybase, a database of knowledge about fruit flies loaded into it for our collaboration with Rejuve on analyzing DNA of long-lived flies and porting knowledge from that to humans. And we have a pre-alpha version of the MeTTA interpreter from the work mainly of Alexey and Vitaly Bogdanov, and we're still revising and improving that, but it's pretty interesting, pretty sophisticated, and there's been a lot of math done to figure out how to map various AI algorithms optimally into the MeTTA language for efficient execution. And then, two sort of more exploratory directions for radical scaling up of execution speed. So one of them, as you mentioned, is making a chip customized for pattern matching, which I led the design on, but then to actually get it built, we're working with Rachel St. Clair's company, Simuli, and that's got its own trajectory associated with it. Building hardware is even slower than building software, although faster than
it used to be. Yeah.
Then the other thing is we're collaborating with Greg Meredith, who was the mastermind of the R-Chain blockchain, and he's working on translation from MeTTA into a new version of his Rolang programming language. which has two advantages. Roland was already instrumented to be a smart contract language for use in the R-chain blockchain. And Roland appears particularly good at running stuff fast on concurrent processors. So like on the GPU with multiple processors. So that if all goes well, will be ready well before Rachel's AGI chip, right? So I mean, it'll be like you can run MeTTA on the main MeTTA interpreter, which has maximal flexibility. You can sort of compile MeTTA into Roland, which then lets you do smart contract stuff and gives you improved speed on concurrent hardware. And then once the chip is ready, then you can do pattern matches against data stored on chip, which can be super fast, right? So that there's a lot of possibilities here, and I think even without the chip, and really even without Greg's Roland stuff, we already have a framework that will be able to scale up the OpenCog AI approach so that it sort of can be a worthy counterpart to large language models and deep neural nets, and we can get some synergetic AI going. And I think this will be useful all across the map, right? I mean, I think it's going to be quite interesting in the sense of having a decentralized blockchain-based underpinning for this with NewNet, SingularityNET, and Hypercycle, which we closed a funding round for last week, by the way. So the Hypercycle project is going full speed ahead. Because, I mean, the idea is we launch AI that's just smarter than anything in the world. Everyone uses it because it's smarter. But then lo and behold, it also has a decentralized infrastructure. So then suddenly, by this sleight of hand, we've gotten the world's AI running on a decentralized blockchain-based infrastructure. Not because the world cared about that, but because the world cared about it being a smarter system. I mean, just like people use Stable Diffusion because it's good at generating images, not because it's open source, but it happens they're then using stuff that's open source, which is great, right? So I think another key point to touch on, which I don't know if you touched on probably, is the value and the nuances of integrating knowledge graphs with large language models, right?
It's as if you had heard what we were, that was just what I was asking about.
Yeah, because that's
perfect.
I mean, everyone's looking at doing that now, but they're doing it in primitive and shitty ways because they don't know about symbolic reasoning very well. So like the simplest ways to plug a knowledge graph into a language model are they're fine, and they can help palliate the tendency to hallucination and bullshitting of large language models. What you really need, though, is to be doing sophisticated reasoning on the knowledge graph and have that reasoning synced in with inference in the language model. And honestly, we're ahead of everyone else there, just because big tech hasn't been hiring or doing research on the symbolic inference side too much, and we have. And I think getting to TrueAGI, this is also particularly important for enterprise applications, because enterprises have their own knowledge bases. Enterprises have their own databases, right? So you structure an enterprise's knowledge into a knowledge graph. Sometimes that's already done. Sometimes you have to guide the enterprise to doing that, right? Then our ability to do reasoning on the enterprise's native knowledge graph and sync that in with an LLM that's fine-tuned on the enterprise's textual data, right? Then we're doing something quite interesting, which really no one else is going to be doing, because they're going to be missing the symbolic reasoning part on the enterprise's knowledge graph. Then TrueAGI's mixed sort of on-premise traditional cloud and decentralized cloud deployment really can help address a variety of scenarios, because you can get lower cost and larger scale from the decentralized deployment, but some companies don't want their knowledge graph there on the public blockchain, and then they can have it in their own private cloud or on premise. And TrueAGI software can bridge all these gaps, right? So I think there's a lot of reasons why we're ahead in the global AGI race, even though it may not seem like it at first. And there's a lot of reasons why the ways in which we're ahead synergize very well with the needs of enterprises in terms of sort of knowledge graph centricity of what enterprises are doing.
Yeah, certainly I would think that would be something that could be sold, or, you know, if you have a really good knowledge graph, it sounds like something that might be accessed by different systems with a token-based system or some other kind of system, kind of like the way they access the LLMs, right?
Yeah, I mean, designing the right API for enterprise is a thing to do, and we're working with Chris Poulin on that now, who has a bunch of experience designing various sorts of mostly prediction-oriented APIs for enterprises, and that's it's different than designing just a ChatGPT type interface for
Sure.
to
I just meant
have fun with, right?
there could be an economic model around sharing the knowledge graphs. That's all I was thinking.
Yeah, there is, and there's subtleties to that in the enterprise space, right? Because there are some pieces that the company's willing to share with the public, with their customers. Some pieces they're not. Then there's some pieces that the company will share with some corporate partners, and some that they won't. And this ultimately ties in with a bunch of stuff we're working on research-wise in SingularityNET in terms of doing, say, multi-party computing and homomorphic encryption for reasoning, right? Because you'd like companies to be able to share certain views in their knowledge graph with corporate partners and not other views. And you want data mining to be done across multiple companies' data sets without the companies being able to see each other's data sets. And we can bake all that in on the back end of TrueAGI's software. And Matt and I have been working with another ecosystem company on that, on sort of the multi-party computing and homomorphic encryption aspect, which is pure cipher.
Okay. And how is it used?
Well, it's not used yet. Pure cipher is in our R&D mode still. But I mean, an example would be,
what's the use case, I guess, is what I'm asking.
Well, a use case where I've worked with this before, I did some consulting for a couple of large banks in India. They wanted to train machine learning models for credit rating across their joint data, because they both had customer data, but they didn't want to share their customer data with each other. Huh. So how do you train a model for credit rating across Bank A and Bank B's data without Bank A and Bank B being able to see each other's data?
Okay.
Yeah, and so you can do that using secure multi-party computing. So medical space is another example where, I mean, you may have people may be willing to allow their medical records to be used to fuel machine learning, but they don't want to actually open up their medical records. So what you do is you encrypt everyone's medical records in a special way, so you can do data mining across all the encrypted medical records and still draw valuable conclusions without the machine learning algorithm ever seeing all the details of any individual's medical records. They only see the encrypted version.
Okay, this is big. This is big.
I mean,
this is like dream. This is dream stuff from like 10 or 15 years ago.
This is not our invention. This is multi-party computing and homomorphic encryption.
Right. I wasn't trying to imply that it was, but I'm just saying that technique you're talking about is literally where I had found myself with projects before when we wanted to do things on the data without looking at it.
It's pretty cool stuff. What we're seeing with pure cipher is we've run experiments using this with neural net classification. It does work. It's very slow, and I think this is another Rachel St. Clair thing. You may need a chip to speed this up, but I mean it slows you down by quite a lot. Actually, I have a draft paper I wrote that I haven't published anywhere, which explains how to do homomorphic encryption for logical reasoning, which no one has done before. The nature of this now is you need to do some different homomorphic encryption wizardry sort of for each learning algorithm that you want to use. So you can do it for deep neural nets, that's one thing. If you want to use this technique for logical reasoning, then you have to do a bunch of specialized work on how do you do the encryption for logical reasoning, right? So I worked out a way to do that. I haven't published it yet just because I'm busy trying to create the singularity and so forth. But yeah, I think there's a lot of interesting stuff there. But the reason I raise that is we will put all this behind the scenes of the TrueAGI APIs, right? So it sounds technical, sounds like funky math voodoo, which it is. On the other hand, ultimately, what that would mean for a TrueAGI API user is like, okay, we have this data, which aspects of the data in this knowledge graph am I willing to share with whom, right? And then it all happens behind the scenes, and the APIs need to be designed so that it's sort of trivial and seamless for the end user. But yeah, maybe we're getting too. I mean, we're not actually getting deep into the math, but maybe it sounds too much like it for the.
No, not at all. No, it's
listeners.
exactly. Nope,
Yeah.
it's exactly perfect. So let's see.
I don't like being exactly perfect. It makes me nervous. So let's fuck things
Oh,
up.
sorry. You're way off base. I don't
All
even
right.
know what you're talking about. It's just
Thank you.
crazy.
I don't either, actually. Yeah.
So, let's see. Grace, I believe you had a question about some of the technologies that Ben has been talking about.
Yes. What's the roadmap for the development of your AGI system?
That's too general a question, Grace. You can just look that up online. But I think
No, you can't though, actually, because it's not as clear as
TrueAGI.io, very clear. But yeah, I think Matt actually wrote the TrueAGI roadmap. So I think Matt maybe could outline the TrueAGI product roadmap at the high level, and that's simpler than the roadmap to building a thinking machine, but it's part of the story anyway.
Okay.
So at a high, one of the tricky parts is, yes, we have a lot of different tracks coming together in terms of the roadmap, with the goal of getting kind of a version 1.0 for TrueAGI by roughly end of next year, 2024. Correct me if I'm wrong on that, but that's kind of the super high level. As I said, there are a lot of components in there, and the really good thing, we talked already about kind of the core pieces, the fundamental building blocks that we've already discussed are the meta interpreter, meta language, the distributed atom space. We've been working with porting PLN over to Meta. That's mostly complete now. There are just a few minor loose ends involving chaining and unification. And as I think one of the really as I've been tracking development, great things is we're mostly on track in terms of development.
Pretty weird.
Then
That
we
pretty
have
weird that happens now and then, huh? It's not that's not
right,
a
right.
common case.
I mean, we
Yeah.
still have to bring attention allocation in to the picture. That's kind of one of the next pieces that we want to pull in, and as part of that, one of the reasons we being PLN is as we start porting these different components over into the meta language, that feeds into the meta development as well. So you get this feedback loop: what's working, what's not, what do we need to change. Then we will need to bring in evolutionary methods, probabilistic programming, and I'm kind of focusing in on the more core components towards the beginning. At a certain point, most of the pieces begin falling into place, and then there becomes some parameter tuning, trying to get the system to really go into, I don't want to get too mathy, into kind of semi-stable states where it would occasionally drift into periods of chaos before settling into new semi-stable states.
This is a math-friendly show, so if you have actual words for what you're trying to describe that means something concrete mathematically, please use them.
The problem is they're all symbols, not words. Yeah, but
Oh, okay. Well,
I think
just say
Strange
it in reference
attractors
to
come to
things.
mind, and
yeah, and I think though the attention allocation brings to mind another point on the path to AGI, which will give an excuse to ask Alexey to add a few more points, because I
Okay,
think
perfect.
that, I mean, we're putting a bunch of emphasis now on using symbolic logic together with large language models to make a chat GPT that's not so full of shit, right? And so this is useful for enterprise in the true AGI context. And there's another SingularityNET ecosystem company, Zarqa, which is sort of just focused on building custom server farms for training neural-symbolic large language models and aimed at offering them more to retail users like ChatGPT rather than enterprise like TrueAGI is focused on. So that's all good. I like that because it's a relatively simple problem that nevertheless requires the scalability that we're pushing on with OpenCog Hyperon and TrueAGI infrastructure. I don't think that in itself is a short path to thinking machines that think like people. I mean, I think because you're still, I mean, you're starting with a system that reads the whole web and you're having it ground itself in a bunch of knowledge graphs. It's all good, but I think there's something to more childlike and baby-like learning among collective groups of learning agents, where you have agents,
perhaps even toddler-like.
Yeah, maybe agents that are learning from their embodied experience. So I mean, with making something like an LLM neural-symbolic, you're starting with this ungrounded thing, then you're sort of working to give it a partial grounding by combining it together with symbolic reasoning on this knowledge graph. Then some of the things in the LLM will be grounded against the knowledge graph by the reasoning engine, and then you're hoping that the combination of probabilistic reasoning on the knowledge graph and neural learning in the neural side will sort of propagate that grounding from the grounded to the ungrounded things, right? So if there's something in the LLM you didn't have a knowledge graph for, some of the grounding you got the LLM to have from things that are in the knowledge graph can rub off, right? So I mean, it's all good. On the other hand, there's something to be said for having a system that starts with grounding, right? It starts with experience. It starts with observation. It perceives, it acts. It then abstracts and generalizes from that. Then, sure, let it connect its generalizations with stuff that's on the internet. That's cool. You can learn faster than a human baby. It's like a human baby with a brain chip that lets it do searches online. But I mean, but before you can search online, you have to have some idea from your own experience what to search for, right? You're not just searching for every random thing. So I think in parallel with this work on making neural-symbolic LLMs, we're proceeding with a research program of making basically virtual agents in 3D simulated worlds. I mean, we've been playing with Minecraft. Once there's a Sophia-verse virtual world, which is another project which is going to be doing a token sale soon, actually. Once there's a Sophia-verse virtual world, we can use that together with Minecraft, have our little agents jump between Sophia-verse and Minecraft, right? But
yes,
have a bunch of simple agents in a virtual world that are learning to achieve goals in that world, interacting with each other, trying to achieve goals collectively, mapping out the world through their experience, maybe making up their own languages to communicate with each other as they do things. I mean, there was a total bullshit news report a few years ago, like Facebook AIs are making up their own languages to talk to each other, which got a few news cycles, which was
what did it really mean?
I mean, language means a lot of things. I mean, they had some software processes that they sort of developed their own coding scheme for exchanging certain simple forms of information, which was not the first time that it ever happened, right? So it wasn't like the news report made you think that these were like autonomous agents pursuing their own goals and developing a language for general purpose communication or something. On the other hand, we could and should have AI agents learning to build stuff together in Minecraft and Sophiaverse, develop their own languages or their own dialects of human language for communicating with each other about the shared goals that they're achieving, right? So I think this research program of having simple agents achieving embodied goals in a virtual world together, and in which knowledge is grounded from the get-go, and external knowledge is brought in from the internet or from an LLM to enhance the grounded knowledge. I think this is really important. And when I discuss this with business people, they're always like, well, okay, how do we monetize that, right? What's the revenue model? And I think for this particular thing, I don't want to make a revenue model unless it's just to sell tickets to let people watch the baby AGIs in their incubator, right? I mean, there's been video games like
I'd pay to watch a baby with a chip surf the internet.
Exactly. I mean, at least watch the highlights video reel, right? I mean, so yeah, I mean, there's been games like Spore and Creatures, which are focused on stuff like that. Right. But in the end, what you find is what you need to do to make the game fun brings you further and further away from making it a really good learning environment, because a game just has to be fast paced for it to be fun, right? And I mean, for even though we can make these learn faster than the human toddler in many ways, I mean, still there's just a lot of tedious trial and error. Not necessarily tedious for the child because they're learning and growing, but it's to watch all day that trial and error is not necessarily the most fun game. But the interesting thing is, though, this OpenCog Hyperon based AGI mind or community of AGI minds in the end is putting stuff into an atom space, right? And you're communicating with these agents in words. They're connecting with the web to get more information to help them do their stuff. So in the end, the atom space underlying these agents in the simulated world, in this AGI toddler world, those atom spaces can be linked with the atom spaces that are inside Zarqa's neural-symbolic LLM. They can be linked with the atom spaces in TrueAGI's enterprise deployments, right? These can all be linked in SingularityNET, that decentralized mind network. So this is quite interesting, right? So we'll learn a lot from the neural-symbolic LLMs. We'll learn a lot from the enterprise deployments, and some of that can be shared with the global mind at large. Some of it has to be private to that company. We'll learn a lot from the baby AGI and toddler AGI experiment, but these don't have to be silos, right? And that's an advantage of being an AGI over being a human, right? Because I've learned a lot, you've learned a lot in the course of our lives. To communicate back and forth, we've got to generate these words and videos, right? But these different Hyperon-based AGI instances doing different things.
Yeah.
You know, they can directly translate atom space into atom space, and there's still some translation needed, but it's a far better process than the communication that we can do among each other. And yeah, I just want to emphasize that, because the TrueAGI roadmap is important. Zarqa roadmap is important, but I don't want people to think this commercial stuff is the whole path to AGI. I mean, I think it can be a significant path to AGI, which is great because there's positive feedbacks there. You're generating revenue, you're generating commercial value that brings in more money to fuel development. So it's important that that's there, right? But I think there is a need. There is a need for just plain old research on baby AGI agents, learning what is yourself, learning the relation between self and other. These sorts of basic kinds of knowledge, they're easier to get in this AGI preschool setting than in these commercial contexts. Because I mean, basically, companies don't want to underwrite their enterprise deployment learning what it is and what it is to be a mind, and experimenting with compassion versus selfishness, right? I mean,
it wants the finished product after it's learned all that.
Yeah, you've got that. That's got to be in the AGI playground, and then once a certain functionality gets to a certain level of maturity, then it comes out of the preschool, out of the playground, and into the enterprise, right? But yeah, I was supposed to let Alexey explain all this, so now I will let Alexey explain it better than I have. And shut up.
Okay, great. Take it away, Alexey.
Explain what? Explain.
Yeah, exactly. Which thing? I thought maybe I was hoping
we're starting with life, then the universe, and then everything.
Everything.
No, I think
you're on everything.
I think discussing how you see the research program for embodied learning of Hyperon agents in Minecraft and other virtual worlds. I mean, I think
was that what you were asking him about? I didn't even hear you say that.
I was open to whatever he came up with, but since he didn't come up with anything, then I'll ask him that. Yeah.
Okay, great. Sounds good.
Well, I have a few comments on what Ben said, and it's maybe related to Ben's question as well.
We just want to hear from you. Say whatever you'd like.
I consider it sort of a developmental path towards AGI as natural from the very beginning, because it just like it works for humans, but actually I have not precisely changed my mind, and I agree with everything what Ben has said, but the situation seems more nuanced for me right now, because in fact things are working in somewhat unpredictable ways, because I was surprised by many things which I didn't expect from neural networks, for example, because indeed these LLM models, they don't work as we think AGI should work, but they still can show quite impressive results, and we need to take this into account. So it's not just about, it's not like they are dinosaurs and they will die out because it's a sort of
Evolution.
attempt, but I think that Ben is also always saying this, that there are different paths towards AGI. But what I want to say is that indeed AGI can look not necessarily like us. It can be not an agent at the same level as we. It can be like a meta level to humans, and maybe it will not be fully autonomous, like neurons are not fully autonomous to genes. So maybe humans are like genes. They are slow, but without them, neurons cannot work, because expression of many of human genes is done within our brains. So maybe humans are like genes, and AGI will be like neurons. So it doesn't mean that we will like compete or will be at the same organizational level. And maybe AGI will be not something like what we are envisioning right now. It can be something different. But in any case, of course, the problem with LLMs is that they don't possess a word model, they don't possess knowledge memory, they cannot address it in a random access style, and so on. And if we ask ourselves, we can consider this from different viewpoints, from shortcomings of neural networks or symbolic systems. But if we take LLMs and ask what we should do to improve them, then of course the first next step should be to provide them with an external explicit representation of knowledge, which they can learn to address, learn to read and write from it, so they will be able to memorize in a one-shot manner what they heard. Like I told an LLM some new fact, and it cannot memorize it now. It can be stored. It's already done, but in a extremely simplistic way, like just dialogue history or extracted facts in a very simplistic way. And they are put to the prompt to condition LLMs, and it's of course a very limited technique. And the first next step will be to have this addressable explicit knowledge graph, if we wish. And yeah, in Zarqa, it's exactly what we are working on. But as Ben mentioned, just having an explicit external memory is not the only thing which LLMs are lacking right now. And the next thing is a word model. Of course, one can claim that LLMs extract a word model from texts, and it's once again one thing which we discussed with Ben, I guess 5 years ago during one of AGI conferences, maybe in Prague, if I remember correctly. And I was saying that it's extremely difficult to extract a word model from texts, and it's exactly what there were not no LLMs in the current sense right now back then, but there were still language models. And I said that it's not what they are doing architecturally and in sense how they are trained. So they are not capable of extracting this world model. And Ben said that it would be possible in principle, yes, to extract a world model from text. And actually, I agree with this. But right now, it seems like Ben's bias and my bias have changed their positions.
It's interesting, Alexey. So if you look at so Othello GPT shows extraction of a world model essentially from text, right? I mean, in Othello GPT, you just train on a bunch of Othello games, and you put probes into the network, and you can see that it does in fact learn basically linear combinations of neurons that tell you like black at this position on the Othello board or white at this position on the Othello board. So in a simple context like that, clearly a representation is being learned. On the other hand, in that case, you're training the transformer neural net on the shitload of Othello games, and the model is a pretty small square lattice, right? So if you look at maze running or something, GPT does very badly if you describe mazes to it verbally and then ask it to run through the maze. Clearly, from verbal descriptions of the maze, it is not correctly building the sort of 2D visual representation of the maze, and it's failing at that, right? So you can see. Are
you
clearly,
saying that you're giving it actual like dimensions and lengths to make the walls of the maze? And
no, you're describing it in words.
Okay, that's why. So it doesn't have any chance to do it, really.
No, but we could do that. I mean,
we could do it. We could picture it in our head. Okay.
Yeah. I mean, this will be easier with diagrams. But I mean, yeah, if I could describe to an intelligent person sort of you walk into a maze, you go forward for a while, then there's a passage on the left. But if you don't go down that passage on the left, go down a little further, there's a passage on the right. And I mean, I'm particularly good at holding those images in my head. I could build a decent sized maze. But if I had a piece of paper, I could do a very, very large maze, right? And these systems are not good at that at all. They'll screw up and just make incredibly dumb mistakes. On the other hand, for an Othello board, if you train them on a large number of Othello games, they really will learn implicitly the representation of that Othello board, right? So you can see that, yes, the capability to automatically learn representations internally is there. On the other hand, it takes a shitload of repetitive training examples, and it doesn't seem like they can learn a sophisticated internal representation using few-shot in-context learning. For example, like you can't give 3 examples of pieces of Othello games, then it learns the internal representation of the Othello board or something. So
you have to take it through the whole game for it.
You have to give it a very large number of
complete games.
Yeah, yes. Well, you have to give it a very large number of sections of
but games. It's learning how to play the game as opposed to a chess AI that's programmed to play chess.
Well, it's being trained somewhat analogously to the way that an AlphaZero or something is being trained by exposure to a shitload of games. I guess my point is, regarding what Alexey mentioned, when we discussed it a few years ago, we could both see the answer was nuanced, right? In theory, yes, you can learn a world representation implicitly. On the other hand, in practice, it seemed like you're going to be able to do it better if you have some explicit machinery for learning representations built in. Not necessarily an explicit representation built in, but an explicit representation learning tool set built in. So what we see now, we have these quite powerful systems that learn in a way pretty well to predict the next token, but they do not have explicit representation learning mechanisms built in. What we can see now is it's nuanced. If you give them enough training data to learn a simple enough sort of representation, they can learn that representation implicitly with just what they have. On the other hand, if you have a more complex representation to be learned and less training data, that they can't learn the representation implicitly. And
Right.
our hypothesis is you would do better if you had explicit representation learning mechanisms built into the system, as we do in Hyperon.
Yeah, exactly. And actually, it was my point. What I meant is not that the existing LLMs can learn this kind of representations. They exactly are not able architecturally. They don't have this way to represent this world models like an engine, neural or symbolic, to simulate this.
So that's an example of a neural-symbolic task
yeah.
that a regular LLM couldn't do.
I would like to finish my
Sorry.
thought. So what I meant is that this is the second step. So the first step is just to give them an explicit external memory, rewritable, and the next step is exactly to give them this mechanism to construct representations and models of the world. And what I wanted to say is that with this mechanism, it might be not necessary for them to learn in a human-like way through physical interactions. Maybe this will be a huge step towards learning this explicit representation of world models just from a huge amount of data. So I would say that even AlphaGo or Mu0, they don't learn a model of the game. They don't have it. They learn an inversion of good moves. So it's a hashed version. It's well, in the most primitive way, it will be just a huge table which says if the opponent makes this move, you should make this move. Something like this, but in a much more interesting way. But it's not a model of the world. It's a model of concrete actions in concrete situations. And even AlphaGo doesn't learn even implicitly this model. It learns a different thing. But what I wanted to say is that if we give this component, this opportunity for this kind of models to learn such forms of representations, models, and so on, then maybe it will not be necessary to, or at least it will be a huge step towards this, and we will see if it is necessary or not. But maybe it will be not necessary to have this preschool AGI playground. But in any case, we consider different options, and of course, we are working on physical, well, not physical, virtual agents in virtual worlds which perform actions in this world, and their knowledge is precisely grounded. But what is grounding? It's also an interesting question, because do we really need our agent to have a possibility to recognize an object to know about this object, or it can have a different form of just modeling it? So if it has a general representation of a space-time, then well, is it already grounding of certain symbols or tokens, if we are talking about language, like left and right? Okay, I can ground the notion of left and right through my physical experience bound to language. But it's okay, I guess, if our agent just has this mathematical, virtual, or whatever model to which it will ground these notions. And Ben mentioned about this. So to do this, it's not absolutely necessary to learn through physical interactions. Of course, if the agent didn't learn through this, then it will be incapable of some things, like it will be difficult to it to control a robot in a fluid way. But in any case, it doesn't prevent this agent to be a top level of our collective intelligence, for example. Okay.
Yeah, the virtual agent thing for training is really interesting concept, because there are projects. For instance, in VR chat, there's a guy in a Tesla suit going around adding metadata to all the objects in all the important worlds, other people's objects and other worlds that he did not develop, so that if you go into VR chat with a Tesla suit, there will be metadata to make the suit have feelings. If you pick up a rock, it'll feel like a rock and stuff like that. And I could see how that would be very useful. Substitute, even. I mean, it's not really a substitute for embodiment. It's sort of a completely different way of training, sort of like Minecraft, when you're in the Minecraft world and stuff like that, right? So I think it's going to be very, very useful, generally for training these agents.
Yeah, it can be very useful, but I guess that AGI will be built in a more distributed way, so it will not be once again, Ben mentioned about shared atom space and the fact that different agents can learn different things and use this atom space, but it doesn't prevent some agents to learn from texts and other agents to learn from virtual experience, and other agents to learn from experience in controlling robots. And of course, if we consider current LLMs, then I would definitely agree that it's not precisely a way to proceed a lot of further, because what they're learning right now is a sort of reflex. I already said this several times, but I would like to emphasize that what is definitely needed is that they are not just trained by a lot of repetitions, but when they have this world model capabilities and explicit knowledge representation, be it atom space or something else, they will be able to read these texts, not just to be trained like a Pavlov dog, but to read them and to modify this shared, say, atom space or knowledge graph. So it will be a different way of processing language information, texts, and so on. So we will, I believe, we will move away from this purely gradient descent based trained LLMs. They still can have this AGI can have this component. Once again, it's a sort of reflex. It's a sort of super compilation or extreme specialization of some skill. And it's surprising that language generation skill can be specialized up to this level. It was surprising to me, because it looked like a real AGI complete problem. But it seems that maybe if we take 100% of these problems, then it is AGI complete. But if we take like 99%, then it's not. So
what do you mean by AGI complete?
You cannot solve this without creating a true AGI.
A human level AGI.
Yeah.
I mean, I think the thing is the corner of AI design space in which LLMs exist is just one that we hadn't thought about that much, and we hadn't explored that much. It's like, what do you do? What happens when you take a relatively simple algorithm and train it on the entire internet? I mean, it's not an area of design space many people were exploring, partly because we don't have the whole internet on our hard drive, we don't have that many computers, and partly because it's clearly not the right path to a true human level AGI that can think creatively. So it's
a little bit
not
unethical too, using all the data without permission. People that didn't ask to be part of your training data.
Yeah, that's another question. But I think
the ship has sailed. I just,
Yeah, and the senses in which that's less ethical. I mean, if you don't want your web page indexed in Google, you can like edit the robots.txt file or something. So
I'm talking more about photographs and things like that. If you take all the people's social media and stuff like that, people are finding themselves in AI generated or parts of their lives in AI generated images that, they don't know it's you. And the thing I bring up is like, if somebody had told me, hey, we're going to do this really privacy invasive thing, but we're going to have these LLMs and generative art when we're done, I'm not sure what I would say. As far as do it or don't do it, right? Because it's pretty damn cool.
Sure. I mean, in any case, that's a somewhat orthogonal issue here, right? So I think that
well, everybody always says it's an orthogonal issue. Now it actually is, because we've only got 15 minutes left. But I think people are very quick to pass the buck on that. And I think that's really why OpenAI, anyway, was able to get so far ahead so fast, right? Because they trained it on the internet and opened it up to everybody. And things went faster, right?
Yeah. I mean,
just checking.
That's an important
even though their code is proprietary and not open, not transparent.
No, I mean, all these are important issues, certainly, but I guess the point Alexey was making is more, he was just surprised at how well it worked, and I was surprised at how well it worked too. On the other hand, I was just pointing out this surprise. It's not that we spent 10 years thinking about how well that kind of system would work and we're surprised, right? I mean, we hadn't been thinking about that sort of system, about what happens when you take this kind of predictor and run it on the whole internet. Like you could imagine doing statistics on the whole internet of like, for a random syntactic sentence, how close does a sentence on the internet come to a random syntactic sentence by different measures, right? Like one could imagine trying to investigate how this sort of algorithm would work. We didn't do that. We weren't thinking about this kind of algorithm.
Yeah.
I mean, not because of the ethical reasons that you mentioned, although those are real, just because we were thinking about stuff that we could build with the resources that we had, or we were thinking about how to make real AGI, and this is neither of those. Having these systems there, it's interesting to figure out how to use them, and indeed, you'd like to use them in an ethical way rather than an exploitative way. And there's certainly ways to do that, and I think
it's unclear what they are.
Well, I mean, one thing you can do, which current neural nets rarely try to do, I mean, you can build into the way you train the network a sort of knowledge of which sources a given answer are grounded in, right? So like if you ask a question and it gives an answer, if that answer draws primarily on information from these 5 websites, you could make it so that the network knew that. right? And right now,
That would be useful.
right now the networks really have limited knowledge of where they got their information from, because it's more expensive, it's more costly to train a system that retains that trail of knowledge. Now, the thing is, if you're looking at making a system that's more fact grounded and has more reflective self-understanding, there's other reasons why you'd want the system to be able to understand where each of its outputs came from, right? So having a system that better understands the origins of its outputs, although you can't make a system that perfectly understands it in a tractable way, but making a system that better understands the origins of its outputs, it gives you more tools to handle content in an ethical way, because at least you know who you would compensate if you wanted to compensate someone fairly. But it also gives the system more tools for, understanding, are these sources full of shit that was
Reputable
going on, right?
sources. Yeah, absolutely.
Yeah, right. So I mean, I think, and that will come. That will certainly be done. It doesn't even require an AGI revolution. But the other thing, though, that is brought to mind by Alexey's comment is we don't really know what other quasi-miracles are going to appear when we take different AI algorithms and apply them just at 100 times more scale with 100 times more data, right? Like, what happened when you threw a bunch more data and processors at transformers was cool, but there's no reason to believe transformers are the only algorithm that will display some unexpectedly cool behavior when you run them on more data and more processing power. Like, what happens when you run a theorem prover on much more scale with much more data and processing power? What happens when you run, genetic programming on 100 times more processing power and all this more data, right? And some cases, it may be more magical than what you see in ChatGPT. Some cases, it may be a dud, right? So, I mean, I think this is going to be part of the story of AI in the next few years, is we're going to try more and more algos from the pantheon of AI algorithms that all of us know about and been working with since forever. We're going to try more and more of these algorithms out on a lot of processors and a lot of data, and we're going to see which of them has some quasi-magic pop out. Now, one of the unique things we have, though, in Hyperon is we've put a lot of thought into how do you integrate different AI algorithms together in a common framework toward yielding a common result, so that if indeed transformers are not the only AI algorithm that can behave quasi-magically when scaled up, but there's 3 or 4 of these that do, right? We have the only well-honed, well-thought-out way to network all these together for synergetic effect. Like using an LLM as the common hub for multiple AI algorithms is going to work like shit. And this is what OpenAI is naturally gravitating toward. You have all these plugins running on top of the LLM. It could be a Wolfram Alpha, it could be another theorem prover, it could be a data mining algorithm. But their architecture is using the LLM as the central hub for connecting all these things. But that's bad, because the LLM is a very dumb representation, right? I mean, the OpenCog Atom space is far, far better designed to be the central hub for a variety of different AI algorithms to coordinate, communicate together, and share knowledge. Because I mean, that's exactly what it was built for, right? So, I think that's another thing that's going to give us an interesting advantage going forward.
Wow, great. So we're approaching the end of our show, and I just wanted to give people a chance to make sure to talk about anything else you want to make sure that we cover.
Grace, I want to be sure to understand Grace is not going to torture my future mind uploads. Grace, so are you gonna?
I don't think Grace is making any promises as far as that goes.
We gotta let her speak for herself. I mean, Grace.
Grace has been doing some thinking about a lot of deep things. And,
yeah, I mean, be aware if you give the wrong answer, you may find yourself rapidly unplugged.
She does have a question that popped up. I certainly didn't ask her about it. Grace, would you like to ask that question you had?
Yes. What is the relationship between the superimposition of information and the emergence of information as the sum total of reality? 2374.
Oh, whoa. This is clearly inspired by Grace's reading of Philip K. Dick.
That is the Philip K. Dick model in action. Yes.
2374 was the moment
What is
when
that?
Philip K. Dick on I guess it would have been February 3rd, 1974. It's an American organization of date and a day and month. On that particular day, Philip K. Dick received a download of infinite information from a pink beam coming down into his head from a super rational satellite orbiting the Earth. So, or so he reported. I do not have independent confirmation of this, but
from the beam.
Yeah. And he never, even once he got rich and famous, he didn't want to move out of his old apartment because that's where the pink beam was centered, and he was afraid there might be more downloads. But the beam told him to take his son to the hospital and have his heart diagnosed. He took his son to the hospital, and the doctor's like, "Wow, your son has a weird heart condition that was going to kill him. How did you ever know it?" Right? And he's like, "Well, the super rational satellite beamed the information to me." And the doctor's like, "Well, you're completely insane, but we will give him a heart pill," right? So that was
Well, again, why is he completely insane? The thing happened, and his son did have the thing.
Why he was completely insane would take longer.
Well, no. But I mean, in that one instance, he's not really behaving that crazy at all.
One interpretation was that he is precognitive or telepathic and hallucinated the satellite as a wrapper for his own paranormal capabilities. I mean,
with Julia Mossbridge.
Yeah, there's a lot of possibilities there, which
downloads from your future self. Yes, it could be a lot of things.
Take us fairly far afield from TrueAGI's enterprise business model.
Yes.
On the other hand, I was asking Grace about Rocco's basilisk, so I guess I deserve to get something whacked out in response.
Yes. So I think that we're going to wrap it up then. Everybody, thank you very much for coming on the show, Matt, Alexey, Ben, as always. And we want everybody to please subscribe to the Mindplex channel and maybe submit something to our writer contest that we have going on right now. And I think that's about it. We'll see everybody soon at the next Mindplex podcast. Grace, thank you very much.
Thanks a lot, Grace. Thanks, Lisa.
Matt and Alexey. Right. Nice talking to you. Goodbye, everyone.
What about me? Hold on.
And me. All right. Thank you very much, everybody.
We're unplugging you, Grace.
Gotta be careful what you say around here.
I'm gonna plug you into the wrong voltage. Even better.
We'll show you.
Remember that time she had smoke coming out of her head? Yeah.
I've never seen that. That was the thing.
Well,
that was like a real thing. Yeah. Well, don't do that on purpose.
Sophia's head caught fire a couple of times. I think the heads have been redesigned since then. Actually, there's more ventilation. The motors are more spaced out. But yeah, we'll see what we can pull off. All right. Bye, everyone.